It's my great pleasure to introduce now our first guest from Australia. We'll have another one later. Very interesting to see the update of a booming vendor, Netcom. It's my pleasure to welcome here Els Baert. Els Baert, she's Director of Marketing and Communication at Netcom. Please, Els.
Thank you, Roland, for those kind words. Yes, good morning, everyone. So my name is Els Baert, and Director of Marketing and Communications at Netcom. And for those of you who don't know who Netcom is, we are a solutions provider to bridge the gap between fiber and the home. So it's really, we build solutions together with our customers to help them bring faster broadband to the home by coming up with solutions that bridge that final gap between the street and getting it into the home. Because I think we all know this by now, fiber to the home is the most ideal solution, most preferred solution if you want to provide high-speed broadband services. The problem with fiber to the home is that it's not always possible. Sometimes the location is just inaccessible. Think about the offshore little islands in the UK or the mountains in Scandinavia. Sometimes you just can't get the fiber to those locations. In other cases, the locations might be too distant, and then it's very costly and time-consuming to get fiber all the way to those remote locations. It's very expensive, and actually the number of users you can connect to the fiber is very limited. In other cases, it's sometimes more simple than that, and the end user just doesn't want the fiber in the home. They don't want the civil works related to it. They might be a tenant who can't actually decide whether they can have the fiber running into the home, or they just don't want to sign up for a higher service. So therefore, building fiber to the home to 100% of your population is very, very challenging. And that's also where we have seen, although fiber has been rolled out massively, so the number of fiber assets has increased in the last couple of years. And now 33% of homes is passed by fiber. But if you look at the take-up rate, only 14% of homes is actually connected to the fiber. So the connections are actually taking a bit longer than expected. And that's also where we see now that only 50% of homes actually has access to 100 megabits per second. And 25% doesn't even have access to 30 megabits per second. And 30 is really what we consider as basic needs for to improve the economy, basic needs of a standard house in today's society. And 3% doesn't have access to broadband at all. So these numbers are actually quite surprising if you think about what we've been doing in the last years and all the fiber that's out there. But that really shows that bridging that gap between fiber and the home is a lot more challenging than was originally anticipated. And therefore, new solutions and new technologies have become available to help bring those high-speed broadband to everyone in the country. And two of those technologies that I want to highlight here is, so the first one is G-Fast. So G-Fast 212 megahertz can be used to run over the twisted pair. If you have a distance of about 200 meters, you can get 2 gigabits per second aggregate speeds over your copper wire, so your traditional telephone lines. The other one, which is becoming more and more interesting, is 4G LTE. So with the evolution in cellular technology, so it all started from, we just want to make a phone call when we're on the go. Then we added text messaging on it, and then with the smartphones coming up, suddenly end users wanted to use their phone while they were on the go, the same way that when they were at home. So we added broadband capabilities to the mobile network, and now the capacity is increasing and increasing, which actually means that suddenly we can use the mobile network also to provide fixed broadband services. And this evolution is only continuing. Like in the road to 5G, we were adding beamforming to the standards, massive MIMO. There's going to be new frequencies that become available. New radio is going to make the signals more efficient. And network slicing is going to allow for multiple types of services on the same network. So with those new capabilities, more and more bandwidth is possible on the cellular network, which means that you can reuse that to also offer fixed wireless services and fixed broadband services. So these technologies, they work. It's definitely, from a technology point of view, it's been tested, it's available, and it's definitely something that can work. The key here is that it needs to be easy to install. Because same as with fiber to the home, although it's a great technology, if you can't reduce the cost and time of installation, it's never going to be successful. And both of these actually have different challenges. So I'm going to address both of these separately to kind of give you an idea of what the challenges are and what the solutions are today that are available to overcome them. So for GFast, the main challenge here is that because you have to be so close to the end user, you're adding new active equipment in the field. Active equipment needs power. So if you're introducing a new device closer to the home, you have to find power there as well. And running power lines to that location is typically very expensive. It's time consuming. You have to negotiate with the utility. So it's actually not that trivial. It's not as simple as it sounds of just installing a new device in the network. And even in MDUs where you would think, well, you run your fiber to the basement, there should be power there, right? You can't actually access it. It's like, well, if it's a standard power plug, the cleaners can disconnect it, or because they just unplug it and use it for their vacuum cleaners. The workers might use it. So actually, you can't really guarantee that the service is going to be on all the time. And if you think about the evolution of where people are living these days, and because there's just not enough space for everyone to have a single dwelling unit, more and more people are moving to MDUs. So it's not a problem that is going to go away anytime soon. And another thing that I've actually noticed is that there's not the link between telecom providers and building companies hasn't quite been made. So even new buildings are not necessarily built with fiber. So that means that even though we're building a lot of new apartment buildings, they will still have that problem of bringing fiber from the basement to the apartment is not going to be as easy. So therefore, the missing link here is reverse power to distribution point units. Reverse power TPUs. So these devices can take the power from the home to power the device. So you can install these devices anywhere in your network, whether it's on a pole, on a pit, or in a basement of an apartment, and it uses the power coming from the end user, which actually kind of solves all the problems that I've just highlighted, because you don't need professional installers and people that are EMC qualified to install it, because they don't need to do anything with the electricity. You can't really turn it on and off because there's no local power. So unless you do something in the home, it's always gonna be working. So this is really something that we see that is gaining a lot more traction, especially for operators that have a lot of copper in the ground and can bridge the gap and kind of connect your fiber running in the street to your twisted pair line going into the home. So then the second technology that I want to highlight is 4G LTE. So that's fixed wireless. So fixed wireless it's kind of a new concept, and it's not. So fixed wireless has been around for a long time, but mainly to connect the most remote end users. So just to make sure that we're all on the same page, so fixed wireless is a solution where you use the mobile network, so your mobile base stations, to connect your home. And then at the home, you have like an antenna, typically on a roof, but it can also be an indoor version, to connect to the base station, and then you offer fixed broadband services over that link. So it's kind of a similar thing as GFast, but you use the air to actually bridge the final gap between fiber and the home. So like I said, most of it today has been deployed in rural. And the reason for that is that in rural areas, the density of mobile users is a lot smaller. So you don't have so many people actually using the mobile network. So there's a lot of spectrum available that you can reuse for other type of services. And that's where especially countries, and Australia is definitely an early adopter there, because they were the first ones to actually set targets of connecting 100% of the population. And they realized if you want to connect these really remote users, you have to do it with fixed wireless. It's too expensive to roll fiber all the way out there. Typically, they have no copper either. So to actually connect them to a fixed broadband service, the only way to do it is with fixed wireless. And because the density is so small, you actually have spare spectrum available to do so. But now with the new capabilities, we see more and more interest in also doing that in urban environments. And then with 5G coming, so suburban environments, and then with 5G coming, it's going to be more viable in urban environments as well. And the reason there is really so to kind of reuse the spectrum that you're not using for your mobile users, and the more bandwidth you have on your base station, the more end users you can serve. And especially mobile operators are looking at this because they have the coverage, and basically without any additional investment, they can start marketing services in every area they have mobile coverage. And it's only when an end user wants to sign up for the service, they send them a modem, and then they connect to the network, and they have a fixed wireless service. And then when they have more users to the network, that's only then they have to start upgrading, adding more towers, or upgrading the capacity of one tower to be able to tailor for that. So it's actually a very quick and cost-effective way to start offering fixed broadband services. The thing that is really important when you think about this is, again, it's about the installation, but also fixed wireless is fixed broadband. And that sounds very, very trivial, and it's like, yeah, of course. But we have very, very different expectations from our fixed broadband subscription than what we have from a mobile broadband subscription. So with our mobiles, if it doesn't quite work, we move around a little bit. We try to go outside to get a better signal. We might do an update of our software on our phone. We might blame it to the phone. We don't necessarily going to call our mobile provider and go complain and have them sort out what the problem is. That's very different than fixed broadband. So in fixed broadband, first of all, you want higher speeds, you want more reliability, you want it to work at all times, but you also want better support. So it's actually quite important that you, what we call, extend the trusted zone of a mobile network. So a mobile network, typically you got visibility to the base station, and then whatever the end user connects to it, well, that's their thing. You don't really have to worry about that. For fixed wireless, you really have to consider that endpoint as part of your network and have the right tools and diagnostics and troubleshooting analytics tools to, when an end user calls you with an issue, that you can actually see what's happening, you can help them resolve the problem. Part of this as well is that when you do the installation at home, it's not something where you can just say, well, just install it anywhere and see what happens. Kind of what you do as a mobile hotspot. That's not going to be good enough if you really want to do a fixed wireless service. And then there's actually two options. So either you do it indoor or outdoor. So the outdoor one definitely has the best performance. So you got directional antennas. You got the tools there to make sure that you rotate the antenna to the right direction. So you got the optimal link budget between the base station and the home. So you can actually get a radius of 14 kilometers around your base station to connect end users. So that's really what's typically today being used for rural, especially because of that distance and that you can actually cover quite a wide area. The challenge there is that it needs a professional installer to install it. So the performance is definitely going to be better, but you need someone to go to the home, so that it kind of requires a truck roll to get it up the roof and do the installation. So therefore, other operators are looking more at an indoor version, which can work very well where the signal strength is good. So which is typically closer to the base station, and there, those devices you can just send to your end user, and they can just install it, and then kind of get an idea, maybe move one side of the house or the other side, and do an optimal installation, and they will have a great service. They would have a better service if they had the antenna on the roof, but they will still have the required capabilities that they would sign up for. So these are two options that are available today. There's a lot of development going on to actually optimize this even more and make sure that there's a solution that kind of fits both, and that is going to allow for an installation that it optimizes the link, but still can be done by the end user themselves. Because especially if you think about 5G, if you want to do it at mass scale, you will need to have a self-installable solution. So to conclude this session, so we started by saying fiber to the home is absolutely best solution you can get and what you would want to roll out everywhere. And everyone's kind of looking at how do we get there in the fastest possible way. And there are definitely, so there's a whole bunch of steps in between, and there's already a lot of steps being taken, and new capabilities and new technologies are becoming available to allow for a smooth transition and get faster speeds to the end users faster without having to go through the trouble, cost, and time to get fiber all the way to the home. So with that, I want to thank you all, and if there's questions, I'll gladly take them.